All right. Hey, y'all. Welcome to CS 431, Intro to Computer Vision. It's like we've got almost everybody. Go ahead and admit everyone in the waiting room. All right. Awesome. Yeah, so I think we're only missing three people. So we will go ahead and get started. Like I said, welcome to class. My name is Jeff Durst, and just to give you a little bit of background about me. So this is my second semester teaching this class. I taught it for the first time in the fall, and it went pretty well. What I would say is last semester I kind of did a lot more theory than application, and it kind of worked because I really like theory because my background's in physics and computational engineering. So we talked a lot about just kind of the nature of visual images. But for this class, over this semester, we're going to cover, um, both the theory and then some applications. And I'll go into everything we're going to talk about this year. But just, I guess, kind of to throw out some background so you guys kind of know a little more about me and why you should listen to anything I have to say. So I got my PhD in physics back around 2009 and started working for the Army. So I worked for the Army Corps of Engineers for about 13 years, working on autonomous systems and unmanned vehicles, and especially unmanned ground vehicles. So there was a lot of CV involved in that in terms of autonomous navigation and sort of lane detection and pedestrian detection and obstacle detection and avoidance. So I did a lot of CV work with that, like I said, for about 13 years. Kind of along the way, I picked up a PhD in computational engineering, which was focused pretty heavily on the idea of agent-based modeling and modeling and simulating autonomous systems, and in particular, understanding how well they perform kind of in an operational setting. So it was a lot of a different kind of CV looking at things like satellite images and terrain maps and trying to figure out where vehicles could operate and how they could operate. So it was stuff like, segmenting out what's a road, lots of road network stuff, and then figuring out, well, which roads are wide enough for, a tank versus which roads you can't go down, you gotta hop into your Humvee or something like that. So that's a pretty brief background. One of the things I learned along the way that I'll talk about a little more in a second is that when you are an engineer and you pick up computer vision, you can pretty much do whatever by and large. There are libraries, there's OpenCV, there's MATLAB. Right, you can kind of pick something up and start using it really fast. So my goal for this class is to focus on, as graduating computer science students, what can you do that another engineer can't, right? Like what's unique about your particular degree and background and projects that sort of makes you better than just say Professor Durst was a computational engineer just getting started 10 years ago and having to do lots of things like hard coding parameters and lots of other goofy stuff you don't really want to do as an engineer or scientist. So that's just a little bit about my background. Like I said, I've been teaching at RIT for a couple of years now. Like I said, this is the second time I'm teaching computer vision. I primarily teach in IGME, so I teach a lot of game design, and especially I teach a lot of AI for game design. And then I was lucky enough to get to teach a class on wargaming. I have a background in that. I've done some wargaming over the years. I forgot to mention. So once I left um, the Army, the Corps of Engineers, I worked at AIS, Assured Information Security, which is actually located in Rome, New York. I worked there remotely for a little over a year and a half, strictly on AIML, not necessarily computer vision in particular, though I did some explosive detection work that involved cameras. But after that, lecturing at RIT here now. Let's see. I'm located out of Vicksburg, Mississippi. So I'm remote, so that's why the class is online. The goal is to have a synchronous course just because I think everyone, including myself, gets a lot more out of it that way. That said, given I'm remote and in a different time zone, that won't always necessarily be possible. That's why I'm recording this lecture. So I'm going to record all the lectures and upload them to my courses relatively soon after I give them. And if there's going to be a day I can't give it in person or live, I guess as close to in person as this is. If I can't do it live, I'll make sure to send out a message within 24 hours to say, hey, y'all, we're meeting tomorrow, or hey, I can't make the lecture tomorrow. I'm gonna upload some info for you. So, since it's the first day, what we're gonna do is just run through the syllabus and just kind of talk about what we're gonna do in the class and how it's gonna work, things like that. And then Thursday, we'll kind of dive into the actual content. So for today, I'm going to share my screen and pull up the syllabus. So this is on, everybody see the syllabus? Thumbs up. All right, I'm going to take that as a yes. So this is the syllabus for this semester and some of the stuff we're going to cover and, all the course policies and all that good stuff you usually do on the first day. So, like I said, we'll mostly be doing a mix of synchronous and asynchronous online. Like I said, I like being able to do it live with everybody. So, we can kind of interact and there's a consistent time for everyone to watch everything without, having to try and worry about getting on my courses on their own time. So the goal is to do live. Set up the Zoom meeting. It's on the My Courses page. I think everyone has it. I emailed it as well. And it's 3:30 to 4:45 Eastern, so that's 2:30 to 3:45 for me, and that's Tuesday, Thursday. And like I said, we'll do it live when we can, and if we can't, I'll let everyone know and upload a lecture later. In terms of location, right? It's online. I'm in Mississippi. It's pretty far away, so it's going to be on Zoom and Discord. There's my Discord name. There's my email for RIT. Discord's going to be the fastest way to get a hold of me. I usually check that a couple times a day. And emails may take up to a couple days for me to get back to you. So if it's kind of an urgent question, send a Discord message or drop a message in the Discord channel, just sort of the general chat or whatever you want to drop it in. Like I said, there's the link. So you can get a hold of me on Discord, or if it's kind of not an emergency and you don't mind waiting a couple days, you can just shoot me an email. I would say the one benefit of email, hopefully this never happens, but if there is ever any kind of conflict or issue you have, I would highly recommend using email just so if I'm a jerk, you have proof, right? So yeah, if it's kind of a serious thing, go email, and if it's kind of a quick question for class, hit me up on Discord. And I've got the server here and the syllabus. So in terms of the course description, like I said, as an intro to computer vision class, it's really my goal to cover a lot of the theory behind it, right? So what makes a digital image, what is special about an image versus some other data structure that's an array, what can go into a digital image that we may not be able to put in different array type structures. So a lot on just kind of the core data structure itself that is behind digital images. And then we're going to go from there and kind of, work our way up the ladder of image processing, like computer vision. So, we kind of start from what is an image, and then we're going to talk for a pretty long time about this idea of image coordinate spaces and coordinate transforms for images and why we do them, what they do them for, what they all are. Because if you can get a really good handle on what an image is and how you can transform back and forth between essentially different coordinate systems or different values, that really illuminates all the different algorithms you have and when and where to use them. So we spend a while on just the underlying theory and how we work with just the numbers in an array to do computer vision. Uh, with that, we're going to use Python and OpenCV a lot. All of the example code I'm going to give is going to be in Python notebooks, and I'm going to want you to turn your assignments in using a Jupyter notebook so I can drop a little bit of tutorial stuff onto the My Courses or the Discord if anyone needs it. I think most people are familiar, but if anyone hasn't used a Jupyter notebook before, let me know and I can put some resources up for that, which I'll probably do that anyway in case you don't know. But anyway, that's the easiest way to do it. And that way I can run your code without having to attempt to do anything. And if it doesn't work, I'll know right away. So we'll be doing Python and OpenCV. We'll be doing most, if not all of it, in notebooks. I'll share the class notebooks. There's going to be a GitHub for the class where you can pull all this stuff and pull some of the outside materials. Once we worked our way through sort of the basics of what is an image and what is a color space and what is a coordinate system, we can look at some of the 2D stuff. Kind of the big ones we're going to hit are going to be filtering, edge detection, shape detection, and image segmentation. Those are kind of the foundational ones. And then you can build off those, and we'll talk about some of the more advanced stuff like image segmentation, clustering, and anomaly detection. And that kind of carries us through the end of the class. Whereas an intro class, my job is to explain what a digital image is and what computer vision is, and how we sort of work in that space. So, and then at the end, we should have some time. It'll be nice to maybe kind of last couple of weeks just look at some different real world applications. There's a lot of stuff I can kind of pull from autonomous navigation and driverless vehicles, and I can give my TED talk on why they're dead end technology at some point, I'm sure. All right. So that's kind of what we're going to cover in learning outcomes, the idea. So my philosophy is there's going to be mostly projects with a midterm and a final that are both comprehensive. So everything up until the midterm will be on the midterm. Everything up until the final from the midterm on will be on the final. We'll set up a way to kind of do it at the same time. So it's not going to be a coding exam. It's going to be, I'll probably send it out at a certain time, give everyone, 2 hours to work on it. And at the end of the 2 hour window, I need to send it back. And that's because it's easy to, like I said, it's really easy to kind of grasp the basics and pull libraries and write programs and, start from the code I give you and update it, right? The writing part of these exams is to really assess, your ability to kind of whiteboard a solution and come up with stuff in a short time frame that you think you could work, and make sure you're really understanding kind of how the concepts all play together inside the broader field of CV and what we're going to be doing. And that's just my philosophy. The projects are going to be more important, obviously, because the coding is important, and there will be more projects. But like I said, there'll be a midterm and a final that will, cover the course material and be done kind of in a timed, handwritten way. See. So the topics are kind of broken down here. I've tried to make everything as free as possible. Any outside resources I send, which I'll, send some usually for every lecture, is all going to be, free stuff. I'm not going to have any articles lined at paywall or anything like that, or books you have to go and buy. We're using the book Computer Vision's Algorithms and Applications by this guy, Richard Slinsky. It's a nice book. It's totally free online. You can just follow this link and download a PDF. I like it because number one, it's free. Number two, it was published in 2002. So a lot of the other CV books you'll find are, 10, 15 years old and are, largely irrelevant because there's not a lot of the AIML stuff in them. So, my goal was to find a book that was both free and, young-ish and relevant. So that's what we're going to do. We're going to kind of follow along with that. I'll also be, like I said, adding supplementary stuff for every lecture, some papers, maybe some videos, some stuff you can kind of look at it in your own time. If you're, really interested in any particular topic or algorithm or section of the class and you want to learn a little more about it, obviously you can reach out to me and I can point you towards, some books, some articles, some repos, some stuff to, go a little beyond just the introductory level. If there's something you're particularly excited in, and I've broken it down kind of following the book according to 5 units. One of the nice things about doing this online is as we go, the format of the course is such that if everyone is really excited about a particular topic or application, we kind of have the option to spend a day just on that, just covering, some little side thing that everyone's super fired up about. So this is kind of a loose outline of what we're going to cover, but there's wiggle room and there are options, both individually to pursue things they're passionate about, and as a course if enough people are really fired up for it. Like I kind of said earlier, the ultimate goal of this class is to teach you the kind of computer vision you can do that engineers cannot, right? There is a reason you are in a computer science degree and not an engineering degree. And that reason means you need to be better at both writing the code and understanding the underlying data structures for digital images. So, and this means, one of the issues in the last class was, I had to crawl through writing C code in Notepad++ so you could run with Python and CV. So none of you have probably ever seen an array full of just not a number printed on a Linux terminal. And I have, and I am intending to make sure you know how to not end up with things like not a number. When we work through a lot of coordinate spaces, the data type can change going from a 3 value array to a 1 value array that's a bit of 0 and 1, or we might go from some amount to an 8-bit image or vice versa. And so for sure, if I'm looking at your project, I should not be seeing errors being thrown about type mismatches or arrays being clipped, right? That is what USCS students do better than, like I said, someone else. So that's kind of keep that in mind throughout the projects, that because this is a CS course, there's an expectation for some elegance in the code you provide and some ways that it is more clever than if someone just pulled an OpenCV library. And, I think that's really important. I hope you guys feel the same. And I hope, it kind of makes sense that it's, your job to know this better than someone who just knows how to call a library. And along those lines, I'll have a calendar up by the time we meet Thursday. I want to kind of hammer everything out, make sure I've got the right stuff scheduled for the right amount of time. But in the meantime, before the actual calendar goes out, this is what we're going to be talking about. Like I said, I've tried to kind of break it down into 5 separate units. So the first thing we're going to talk about is foundational knowledge. So, what actually is a digital image? How is it different from other digital data constructs? How do we process them? And in particular, how do we do coordinate transforms and work in different color spaces? After that, we're going to, kind of put all that together in Python once we're done with a little bit of theory and just sort of go over how we actually work with these in code, kind of what they look like, what forming and manipulating images is like with Python and OpenCV, and then the foundational algorithms that are sort of all other CV is built upon some variation of a filter, edge detector, and image segmentation. It's all just that plus anomaly detection with extra steps. So we're going to talk a lot about that and a little bit less about the extra steps that come at the end of understanding all the foundational algorithms. Next, we'll talk about some basic 2D image processing. So this will be, actually applying some of the foundational CV stuff in more complicated cases and solving some problems. After that, we'll do, the more advanced stuff, and that's going to be the segmentation, clustering, anomaly detection. And if we have time, some of the basics of 3D computer vision, though that's largely saved for the second section of this course. So if you go on to take, the follow-on course, you will do a lot of 3D. I'm only going to touch on it a bit. And at the end, we'll touch on some real-world applications, especially some of the stuff in the book I've got versus some of the older books, where we are going to talk a little bit about AI and ML as it pertains to computer vision. And this will be, hopefully we can work in some of the stuff I've worked on with autonomous navigation and any, other fun, kind of more advanced CV stuff folks are interested in and we have time to study. All right. So the breakdown of the grading, there's going to be a project on the first 2 units. There'll be a project on the second unit, the midterm, project for unit 4 and a project for unit 5, and then a final exam. And grades are on a 10-point scale. I do not do kind of a plus minus. That's a little archaic, I suppose, to me. So anything above a 90 is an A plus, right? Anything from an 80 to an 89 is a B plus, so on. So if you're in the 90 to 100 range, a 91 is worth as much as a 99. So 10-point scale. Late work, life happens. I do stuff late all the time. It's just part of it. You've got up to 5 days with a 5% penalty for each day. So essentially, you have a week to get something turned in if for some reason you fall behind. And if something catastrophic happens, you're going to be even more behind. Just reach out, let me know, and if it's a special case, I'll definitely be willing to work with you. So expectations, this is a pretty normal stuff. Read the syllabus, come to the class, do the work. Email me if you have questions. This is a 400 level class, so I think it's fair to expect closer to 9 or 10 hours outside of class each week. Because again, you're about to graduate. It's a 400 level class, so life should be a little harder, and it should take a little more work. And I do plan on giving a fair amount of outside resources that'll be worth looking into. As far as writing standards, I just threw this in here. I'm not, huge on email etiquette. That's kind of going by the wayside, I think, everywhere. Just, be respectful, be professional, use good grammar, make sure you are getting your point across, but, you don't need to worry about being super formal or following any sort of structure. You can just call me Professor Durst. You don't need to call me Doctor. Professor Durst is fine. And that's about as formal as it's going to get. And I will say for the assignments, so for the notebooks you're going to be turning in, the easier it is to read the code, the better it is for both of us. And like I said, you're at a level where the code you produce should have a certain amount of optimization and elegance that should lend it to being much easier to understand just by virtue of where you are in your education. So yeah, if I can read it, I can grade it. And if I can't read it, I'm lazy and I won't try very hard. So make sure everything's written really well. Make sure I understand your code and Just be courteous and professional in your emails. Don't worry too much about formality beyond that. In terms of, just expectations and the usual stuff. I'll get back to you on email within 2 days. If you don't want to wait 2 days, or if it's a simple question, or if it's a question you think other people might have, drop it in the Discord. And if you need something soon within a day, just like I said, message me on Discord. So that's, kind of the communication and everything, up through what we're going to cover, the grading, the projects, kind of the basic expectations. So to go through a few policies with generative AI, I am not a huge fan. It kind of is coming to as good as it's going to get um, for a lot of reasons, but everyone is going to use it, and it is very, very powerful for some of the things it is very, very good at. It's kind of the equivalent of when I was in school. They swore we would never have access to a calculator, so we had to learn how to do long division. And now that my kids are in high school, it's you won't have access to Google everywhere you go to look up a answer to a question, and now they do. So everyone has Google now, and I think generative AI is sort of the next iteration where no matter how hard the old folks try, it's just a resource you will always have that can provide a very fast and excellent answer to some questions and problems. So I know you're going to use it. I use it. Some of the notebooks I put together for the class are written in ChatGPT. And so my goal is to, throughout the class and the demos, show which parts have been written by generative AI and when those parts have broken, right? And then how to kind of string stuff together. So I want you to leave the class knowing really what the limitations of Gen AI are and what you can and cannot use them for to make your life easier. That said, you know, if you are using generative AI, especially ChatGPT, there are 40 of you. I should not see the same code twice. And I had to put a note in here because it's happened more than once that I will get the same code with the same comments for an assignment. So if that happens, we're going to have a pretty big problem. So that said, you can use it. I'm going to try and help you know when to use it. But if it's all you use, it will be very, very obvious everything was written with generative AI, and we will have ourselves a problem. So let's see. In terms of discussion, like I said, just be nice, be courteous, don't be jerks. Be professional, be respectful when talking to each other, talking to me. I hope that the Discord server is a place to put some good resources and a good forum for some communication across the class. And I hope everyone can use it and talk and, like I said, share resources and use that as a good resource. Kind of have that as part of our course. And then the rest is just boilerplate. Don't cheat. And I will happily make accommodations for people who need them. I've already gone ahead and approved a lot of stuff through the DSO, and even if it's not, officially through RIT, if you need some help or need a little time, however it works out, you can always ask me. Right? I would rather you say something is going to be late than just turn it in late and hope I don't notice or accept, the penalty when we can kind of work something out beforehand if there's, a serious legitimate concern in terms of getting the work done on time. And I think that is just about it for the syllabus. Let's see if I missed anything. No, okay. So we'll wrap up here in a second. Like I said, we're just going to go through the syllabus today. By Thursday when we meet, I'll have kind of a calendar with what we'll cover week by week and when you can expect projects and exams to happen. And then we'll kind of start our first lecture and go into, like I said, what a digital image actually is versus other types of data you can work with and how we sort of use that to do computer vision. And again, like I said, my main thing is, I want you to leave this class knowing how CV works and being better at computer vision than, an electrical engineer or a mechanical engineer that's coming out of school competing for the same jobs as you are, essentially. And it's something, you really need to be good at, passionate about, because professionally, the sort of instinct a lot of hiring managers still have is to just go after engineers. And so, it's my job, and then, sort of by the transitive property, your job to really know what it is that sets you apart from, an engineer in terms of your ability to do really good computer vision. And hopefully it'll also be fun. It's a super fun topic. There's all kinds of cool applications. Some of the assignments will kind of focus on some of the more fun parts that are, common problems that people have solved that people like. So hopefully it'll be fun in addition to being informative. But that is, yeah, that's my spiel. That's kind of our goal for this semester. We want to learn how computer vision works, and we want to be better at computer vision than everyone else. And yeah, I guess with that, I can go ahead and open it up to questions. If anyone has any questions, comments, want to drop anything in the chat. Um,
Hi, Professor.
yes.
I tried to do the Discord link in the syllabus, but it said the link was expired.
Yeah. So that's because that's the link for last semester that I didn't change. So the one I dropped in the chat should work. And then I uploaded a corrected syllabus. So yeah, if you weren't able to get on with the link in the first syllabus, that's my bad. That's on me. The new link is in the chat in the syllabus, and I'll go ahead and just send it as an email as well once we wrap up the lecture.
Thank you.
I think the new link is also expired.
I'm not.
It's not working.
All right.
Yeah,
All right.
I'm sorry. I was about to mention I'm not seeing anything on my chat for the link. Not sure why.
All right. No worries. Well, I'll drop an email, and if you're still having problems, email me back, and I'll just try and get it sorted out as quick as I can. All right. Fabulous. Well, thanks, y'all. Appreciate everyone joining in. Looking forward to the semester. Glad you're all here. And I'll talk to you guys on Thursday. All right. Bye.